Now that we have gone over what real numbers are, what we want to do is look at the properties that are involved in the operations of real numbers. Specifically, we're going to look at addition and multiplication. So these are the general rules, and it simply says let A, B, and C be real numbers. Now we're going to use this concept that A, B, and C are real numbers and not imaginary numbers to prove all these different properties. The first property is the closure property. That simply means that if I have two real numbers, such as A and B, my result in addition would be a real number. The same would be for multiplication. So if I had 3 times 5, 3 times 5 is a real number, since 3 and 5 are real numbers. And the same holds true if I had 3 plus 5 for the addition property. That will be a real number as well. The second property we have is the commutative property. And we still use the same concept that A, B, and C are real numbers. In the commutative property, we can rotate, or we can switch rather, our different numbers. So A plus B is equal to B plus A. That's the same or similar to saying 3 plus 5 is equal to 5 plus 3. Since 3 plus 5 is 8, then 5 plus 3 will be 8. It's the same with multiplication. 2 times 3 is equal to 6, and so is 3 times 2. That property is called the commutative property. Now, all of these properties you need to know and memorize because they will come back in different sections and topics in Algebra 2, pre-calculus, calculus, or any other math topic that you want to take. Similarly, we have the associative property, and we're going to continue that A, B, and C are real numbers. Now, with the associative property, what we can do is group terms together. And so here you see in the first one under addition, we have A plus B as a quantity plus C. With the associative property, I can move that group from the A plus B to the B plus C. And so if I had 2 plus 3 as a quantity, well, that would be 5. And if I was adding it on to 2, well, 5 plus 2 would be 7. Well, the same holds true if I was to group the last two terms. And instead of saying 5 plus 3 first, I said 3 plus 2, and then added the first number, and I'll still get the 7. The same can happen with multiplication. I can have 2 times 3 times 4, and I could say 2 times 3 first, which will give me 6, and 6 times 4 gives me 24. Alternatively, I could have 2 times 3 times 4, and I can multiply the 3 times the 4, and then multiply the 2 to get 24. Now, the identity property, you will see this often as well throughout the chapters in Algebra 2. The identity property for addition simply means whatever operation you're dealing with, whatever gets you back to the original number is considered to be the identity. So the identity for addition is 0. 5 plus 0 is 5. 7 plus 0 is 5. And alternatively, you can use the commutative property, and you can commute or switch the 0 and the A. So 0 plus A is also A. So 0 plus 5 is 5. 5 plus 0 is 5. 7 plus 0 is 7. 0 plus 7 is 7. So the identity property also has the commutative attribute. And in multiplication, the identity is not 0, but 1. 1 times any number is still itself. And it also has the commutative property. So 5 times 1 is 5. 1 times 5 is also 5. It's the same with any number that you choose. 8 times 1 is 8, and 1 times 8 is 8. The last property that we have here is the inverse property. Now, the inverse property just simply says if you do the operation or the operation of, let me rephrase that. The inverse property simply says that if you have a number and you take its inverse and you put them together, then you will get 0, the identity. If it's in multiplication and you do the inverse operation and you put them together, you will get the inverse for multiplication, or the identity for multiplication, which is 1. So let's try it out with a few numbers. And you could write these numbers down. 5 plus negative 5. Think about it. If I have $5 and I owe someone $5 and I pay them off, I end up with 0. So 5 plus negative 5 is 0. The same works if I had 8. 8 plus negative 8 is also 0. With our multiplication, if I have 7 times 1 over 7, a seventh it will equal to 1. A seventh of 7 is 1. It's the same with any other number. A quarter of 4 is 1. That's why 4 quarters, if I took one of them, I would have 1 out of 4. And so these are inverses of each other in the multiplication property or operation. Now the last property is actually can go across to other operations, but this one is called the distributive property. And we say we distribute the item on the outside into the quantity, every item within the quantity. And we're going to do this often. And so A times B, A times the quantity B plus C is going to be equal to A times B plus A times C. Now often we put arrows to show that we're going to multiply everything by the term on the outside. But once again, we're going to do a lot of these. But what you want to do is make sure you take the time to go over these and study them. All right, one other thing that we want to add to this is that the opposite or additive inverse that we were just talking about under the addition is any number, simply its negation. The reciprocal is the name of the inverse for the multiplication operation. So if you hear the word additive inverse, we're talking about the inverse for addition. And if you hear the term multiplicative inverse, we're talking about the inverse for multiplication. Now, sometimes we can use this concept to manipulate things. And the biggest one that you want to see here is A subtract B. We can also rewrite that as A plus negative B. Similarly, at the bottom, the fraction A over B can be rewritten by pulling out the numerator as a separate number and then multiplying it by the fraction 1 over B. Remember, any number can be rewritten as a fraction as that number over 1. So A can be written as A over 1, and when you multiply fractions, you multiply straight across. So A times 1 is A, B times 1 is B, and you notice that A times the fraction 1 over B is the same as A over B. Now what we want to do now is look over what we call unit analysis. That simply means that whenever you perform a calculation, you always want to make sure your answers or your units are correct. And so if you're dealing with feet, your answer should be in feet, not in meters. If you're dealing with hours, your last answer should be dealing with some type of hours or miles, whatever is there. But what we also want to bring in is that the same rules that you learned in pre-algebra or algebra carry on here. And so when a number is divided by itself, it cancels out to 1. Keep that in mind for part B and C. So for part A, because we're both dealing with feet here, 935 feet plus 285 feet, you would just add the two numbers together. Make sure you always have your answer, or rather your units in your answer. And so we have 1,220 feet as our final answer. Now for part B, we're going to utilize that concept of a number divided by itself is 1, or it cancels out to 1. So if I have 2.5 hours times 30 miles per hour, the word per can represent the division or the fraction bar. Then what will happen is that the hours in the first number is actually in the numerator. Remember, any number can be written as a fraction over 1. So there's an imaginary denominator of 1 underneath the 2.5 hours. So that means the hours are over the other hour and can cancel out. And because they cancel, that shows what unit I will end up in my final answer. So we have 2.5 times 30, which is simply 75. And we keep the unit that's left over, which is miles. So my final answer there is 75 miles. Now we're going to work on this with some word problems pretty soon to see how we actually can know when to cancel. All right, for the last part there in C, we have 75 feet per second times 3,600 seconds in an hour times 1 mile in 5,280 feet. Now this is a conversion that is used to work out how much feet per second is in the same in miles per hour. Now we will work on questions like these as we go forward. So what happens here is we just cancel out whatever is diagonally opposite each other, or whatever is right above each other. And because seconds are there, we can cancel out the seconds diagonally. We can also cancel out the feet that are separated from in the front and the back. And so the fee cancels out as well. And what we are left with is miles per hour, per representing the division of the fraction bar. And then we simply multiply our numbers, 75 times 3600. And then, since 5,280 is at the bottom, we're going to divide that final answer. So 75 times 3600. Once you get your answer, divide that by 5,280, and your answer will be 51.136. And that 36 is repetitive. It's a repeating decimal, forgive me there. It's a repeating decimal only on the 36 part. So that line only goes above the 36, not the 1. And so our answer there is 51.136 miles per hour. Now, I should say approximately, forgive me for that, but make sure you put the approximation sign. All right, let's go into a real life situation and our last question for this video. You're exchanging $900 for Mexican pesos. The exchange rate is 21.95 pesos per dollar, and the bank charges a 6% fee to make the exchange. For part A, how much money should you take to the bank if you do not want to use part of the $900 to pay the exchange fee? So for this question here, just picture yourself going on a trip to Mexico, and I use the exchange rate, that is the going exchange rate, and a kind of a high fee there, 6%. I actually changed it to 3, I believe, in part A. So go ahead and change 6% to 3%. Just cross that out if you're taking notes. All right, so what we're going to do now is just going to find out, well, what would be the rate that I want to have the money at. So once they take 3%, off my amount, that I still have $900. And so to find that, we're going to do 3% times $900. If you should remember this from pre-algebra or algebra, this is how you find out your higher rate. So 3% times 900, well, in your fraction, in your calculator, you want to put 0.03 because that's what 3% is. Remember, 3% means 3 per 100, and per 100 is the same as saying 3 hundredths, right? Per means to divide, so 3 hundredths as a decimal is 0.03. So we have 3 hundredths times $900. That gives us $27. So if we were to add these two together, 900 plus 27, then 3% of $927 will bring us back down to 900. All right, so that's how we figure out how much money we should take to the bank. So once the bank charges the 3% fee, we will be left with $900. All right. So how much money will you receive back in pesos? So the bank keeps the $27. Now they're going to convert the $900. And how much money would that be? Well, it's pretty easy, as you just say it basically how you read it. And so you have $900, changing it to Mexican pesos, which is 21.95 pesos per dollar. Now that word per means to divide. So basically your exchange rate is 21.95 divided by $1, because that's what 21.95 pesos per dollar means. So you have 900 times that amount. So $900 times the 21.95 per dollar, per $1. Okay, so now you just multiply that and make sure you cancel. And what will you cancel? That's right, the dollars. So the dollars cancels out. You multiply the 900 by the 21.95, and your answer will be in pesos. And so your answer would be 19,755,000 pesos. All right, let's go to part C. And I'll put that working back in there so you can see that. All right, so part C says, when you return from Mexico, you have 675 pesos left. So you spent a good bit of money on this trip. How much can you get back in dollars? Well, first assume that you use your other money to pay the exchange fee. So don't worry about trying to do a percent change. Just use the 675 pesos that you have and return it back to dollars. Now, this one just uses common sense as well. I have 675 pesos. I know I'm going to multiply it by the exchange rate, but now I'm doing the opposite with multiplication. Do you remember what do we call that? The opposite of multiplication? What property, what name is that? Well, that's the inverse property. And so since we're doing the inverse of what we just did when we exchanged it to dollars to pesos, we will simply reciprocate, do the reciprocal of the exchange rate. So instead of 21.95 pesos per dollar, we're going to have $1 per 21.95 pesos. Remember, that's called the multiplicative inverse. Okay, so now we just simply multiply and remember to cancel the diagonal-like terms there. And so those units cancel, the pesos cancel, and we're left with dollars. And so 675 times $1, 675 times 1 over 21.95. You could times the $1, so you have $675 over 21.95. And so you divide those two terms, and once you do that, you would get $30.75 left over. So it would be a good trip. You spent a good bit of money. Hopefully you got a good bit of things if this was a realistic situation. But you can always use this same scenario with any fiat currency. So dollars to UK pounds or dollars to Japanese yen. You could do this as long as you find the exchange rate. So Google can do it for you. You can just type it in Google, but now you know how to do it on your own. All right, just remember to do the canceling out of the units, making sure you always have the correct unit, and you'll do totally fine on any type of question.